All right, welcome back. Same lesson. We're still working on transformation of functions. And the last video we looked at parent functions. This video I'm going to give you some examples of how to transform them. So instead of, now the radical is just a symbol. So instead of radical here, call it the square root. So in the Google Classroom, I have put this as a blank sheet that I would suggest filling out as I'm going through it. So any notes that I'm giving you over time, I would make sure you have copies of it or put it on a separate sheet of paper. Don't just watch the video without writing it down. I'm a person that I believe that if you see it, hear it, write it down, you're going to remember it better. So first thing, take a minute and look at these 5 functions and create. So right now you're going to have two letters for each. You're going to have a name that matches it from what we just took notes on, and the equation. So if you need to pause this video, we're going to keep going with live classroom. If you need to pause, take a moment and go ahead and write the names. But we're going to go ahead right now. Everyone else has done this for about a minute. So number 1, what is the name first of all?
Linear.
Okay, so we have which letter?
C.
So we got C, and what was the equation for it?
F.
Okay, so we got C and F. Number 2, what is the name? Quadratic, which is D, and what's the equation?
G.
Okay, y equals x squared, which is G. 3, we have that long S. What is that called?
Cubic.
Okay, cubic, which is B, and what's the equation of it? Yep, x to the...
X cubed.
Okay, cubic, remember third power, so it's H. So we got y equals x cubed. All right, so number 4, that V was which is which letter? And what's the equation of it? Okay, so A and I. And then this one I said to change it to, say, so square root is E, and then it's going to be...
The square root of y equals the square root of x.
So E and J. Okay, so from here, we have these are a parent function we just took notes on. So I want you to think about a problem. We had vertex form. So this right here is vertex form. Think about, remember that was a shifting form, up, down, left, right. So think back to our second unit on quadratics. How did the A shift the graph? Graydon, what's one thing?
It was the stretch of the graph.
Okay, A is your stretch. It makes it either wide, if it was like a half or a fourth, or narrow if it was 2 or 3. So it's the stretch. What else did it do to the graph? Anyone else remember? What else did A do? Go ahead, Graydon.
It determined if the graph was going to open up or down.
Okay, if it opens up or if it opens down. When did it open up? Okay, when A was positive. When did it open down? If A was negative. Okay, so A was our stretch, our shrink if it was a half, because it shrinked it really vertically, and a stretch if it was like 2. For number 12, it says describe the effect of H. So how did H affect the graph? What did it move it? Do you remember which way did it move?
It moved the vertex.
Okay, so which way? What was that called? Help her. She's got it. She got it perfectly. Which one?
Horizontal.
Okay, horizontal, which is what direction from 0? It's going to the left or right. It moved it to the right if it was actually what? Remember, we had to think of the opposite. If it was negative, a negative would move it to the right, and it moves it to the left if it was actually positive. Remember, we'll get to problems like that in a minute. It was kind of the opposite. Number 13, how did the K affect the graph? That was the up or down. The up if it was positive, down if it was negative. Okay, so that's what we already know. So take a moment. Graydon, will you erase that real quick? Like in 2 seconds.
Wait, somebody stole my eraser.
It's right there.
Oh,
There's
you
one.
stole my eraser.
Go, quick. I'm just picking on you. Your mom's gonna think I abuse you like a military in this video. Don't have your mom watch this. No, I'm just kidding. I think she likes me. It's all right. All right, number 6. All right, so what we're gonna do is we're gonna look at the function and we're going to see the name. Is that better? No, not yet. Can you see that okay, guys?
I think if we shut the lights off, we might show
Oh yeah,
it.
can you shut the light off?
Yeah.
Sorry about that, yeah. All right, yeah, I hope,
I don't know what that light does.
yeah, it's fine. Let's try it. Okay, so for this, we're gonna look at the parent function. So think about your names. So the name I want you to put first, and then we're gonna list the transformations before we even start graphing. So we'll go gradual. Okay, what is the name? So if you see second degree, what is it called? Okay, so for the name, I want you to put quadratic. Okay, so think about, okay, what's the transformation? What's one transformation here? What's it getting moved? To the what?
Down 6.
Okay, it's moved down 6, sure. Down 6. Okay, what does the -1 inside move it to?
To the right one.
To the right 1. Right 1. And the stretch of 3. Stretch. I can't spell today. Stretch of 3. Stretch of 3. Okay, so that's what I want. So basically what I would like you to do, when we're graphing, I want this information before we even start graphing. All right, so look at 7. What is the name for that one? Cubic. We have cubic because it's the third degree. Cubic. What's one transformation here? Down 11. Down 11. Left or right?
Right.
Right how many?
2.
Right 2. And what's the 5 out front mean?
A stretch of 5.
Stretch of 5. Of 5. Okay. So what, can you tell me what that would look like? What does this graph look like? Okay, that long S-shaped graph. Good. What did number 6 look like? What's the shape? A U. Okay. Touchdown. Okay. All right, number 8. What's the name for number 8? Absolute value. Absolute value. Okay, what are the transformations? There's 2 here. What's the +6 mean? Okay, it's going the opposite. Remember, what do we have to put in to make that equal 0? We'd have to put in a -6. So it's going to the left 6. Okay, what's the 2/3 mean? Okay, and because it's 2/3, it's really wider. Is that stretching your graph?
Shrink.
I'm going to write the word shrink of 2/3. Shrink of 2/3. It's a stretch or shrink. It's really going to be a shrink if it's a fractional value between 0 and 1. So that's why I'll put that, because it's going to make it wider than the parent function. Okay, the last one. This is probably the hardest one. Which one is this?
Linear.
And what's the only thing that's happening to it? It's going, okay, it would be left 6 if there was parentheses there. No parentheses, so it's up 6. Up 6, and then, yeah, won't talk about that yet. And then for this, for number 10, let's do the last one we'll look together. So read the problem, and I want you to just write what is happening here. So what is happening for number 10? So you got 2 parabolas. What are they really changed? The x squared plus 2 to the x squared minus 3. What's the change? It's going down how much? It's going down on the y. How many, Isla?
5.
Down 5. It's going from up to a parabola, same parabola, going down to minus 3. So it's taking this same graph, shifting it down 5. Okay, so let's turn it over to the other side of the graph. You want to erase it again?
Yes.
Perfect. I'll probably pause when I do real videos like this. Thank you, sir.
You're welcome.
All right. Robbie, will you read the directions of what we're asked to do for these?
Name the parent function, list the transformations, graph each equation.
Okay, so when you're graphing, and I'm going to give more practice on this on Monday, will be your next, I'll probably upload it earlier, probably Wednesday or Thursday of this week. But I'm going to have, this is going to be due by Monday. Probably the next assignment will be Tuesday or Wednesday. I'll have a plan, put it in Google Classroom. So you'll have more practice on this later on. But when you're graphing, I want you to look at, I want you to name it, the transformations, and then we're going to graph it. So what kind of function is this? What's the name, the parent function?
Quadratic.
It is quadratic. Okay, so then what are the two things happening to this quadratic? Okay, it's going down 3. I like to put the other one first because I go left or right first in my brain. Left 2, which is not wrong. I'm going to put left 2 and then down 3. So left 2, down 3. Okay, so I want everyone to show me what a quadratic looks like. So how I modeled, I want you to show me. Everyone. Got yes? Show me show me. Use your arm. Yeah, there we go. Okay, we got that. Everyone. Oh, low battery. Okay. Oh, okay. Everyone was showing me quadratic. I thought the video had stopped. We're good. So we had quadratic. So from there, so knowing the pattern of what each function looks like is crucial. So we know it goes to the left 2, down 3. That's our parent function, the 0, 0, that's getting shifted. So left 2, down 3. And so we know it's our u. So from there, what's the pattern of a parabola? So we go over 1 and up what?
1.
Up 1 in each direction because it's our u. We go over 2 and up how many? 4. Over 2 and up 4. So it should be at 0, 1. And then it's a symmetrical point on the other side. And there is our parabola that shifted to the left 2, down 3. Okay, and for 19, so I want you to write the name and then what's happening to it. So what's the name to start with?
Absolute value.
Absolute value. Okay, what's the name, or what's happening? That's the name of it. What's happening to the absolute value function here? It's getting shifted to the left or right? Right how many?
3.
Right 3, up or down?
Up
Up how many?
2.
Up 2. And what's our stretch?
2.
Stretch of 2. Okay, so from there, okay, I want everyone to show me what does absolute value look like. Okay, everyone is showing me a V. Absolute value is a V function. It's all good. All right, so we got that V. So that bottom of the V is also symmetrical like our parabola, but doesn't make a U. So we have that V. Where's that start out at? What's that point? It also is the vertex of it.
3, 2.
Okay, 3, 2. You go to the right 3 and up 2, so it's 3, 2. Okay, but if it's a stretch of 2, so think about on either side of a V, what shape is it? It's a line. And what does a line have? Has slope. So really, you can think of your A. The A is 2, and that's really like our slope. And it's really just the M, the slope of the right side. So you can think of that as the slope of the right side. So if you go over 1, I have to go up what?
2.
Or up 2 over 1, up 2 over 1. So I have that slope of 2 on the right side, and it's symmetrical. So I go up 2 into the left 1, up 2 into the left 1. So to make that V from the vertex, it has a slope of 2 on either side, and you just go up 2 over 1 in either direction from the V. Up to the right one and up to the left one. So any question on making an absolute value? Okay.
What's the A plus 2?
So A is 2. That's our, if this right here, the number in front is, you can think of really the slope, the M. Here, I won't even make it messy. So if that's a 2 there, you can really think of that as the slope, because a V is really a line on either side of the vertex. All right, so any questions on 1 or 2? Okay, so number 3, what function is this?
Cubic.
It is a cubic. And what's the only thing that this cubic is going?
Down 1.
Down 1, because it's not in parentheses. It's down 1. Cubic, okay, I want everyone to show me cubic. As much as you can. Long, long S. So we should be looking like this. You got the long S or this. Okay, all right, perfect. Good job. All right, so then if we shifted down 1, we go down 1. So remember, to make that long S, we have to go 1 away in either direction from where we're going down. Okay, so we have over 1 and up 1 in either direction. So from this starting point, which would be 0, -1, if I go over 2, I have to go up how many?
8.
Because it's 2 cubed. So it's going to be at 2, 7. And if I go to the left 2, I have to go down how many? Is it a 10 by 10 grid?
Yeah.
So if I just go up 1, I'm good? It's at 9, -9? So it's 8 away in either direction from the starting point, from here. And it should make that S-shaped graph. So a little bit more like this. Okay. So are we good with cubic? So think of its cubes away. So from where we went down 1, it's 1 either direction. And then we go over 2 and 8 in either direction. All right, the last one we're going to look at together. So for number 21, what name is this function? Square root. So what is really the only thing we are doing here? So it's inside, so it's going to the left. Left 5. So it's going to the left 5. Okay, so show me what square root looks like. All right, everyone. Right here, square root. Liam, square root? Okay, perfect. Okay, it's from the elbow. It's like a half of a sideways U. So it's taking this function right here and moving it to the left 5 only. Okay, so where does it start out at?
-5.
But it's moving it to the left 5, so it's at -5, 0. 1, 2. That's if you put -5, and this is how you can make it think. You can think through it. So -5 plus 5 is what?
0.
What's the square root of 0? So it starts at 0, 0. What's the pattern of this? How much away?
1.
Okay, 1 away. So it's like putting -4 in. -4 plus 5 is 1. What's the square root of 1? So if I put -4 in, I get out 1. Okay, so what if I go up 2, I have to go over how many? 4. It's a sideways U. So I have to go up 2, 1, 2, 3, 4. So let's think about this if it would make sense. So what number, so we think about our perfect squares, are 0, 1, and 4. What number would I have to put in for x to be 4? -1, which is that right here. What's the output if I put -1 in? 2. So -1, 2 is the point. So you can think of, if you don't think of the pattern, think about what number do I have to put in to be 9?
3. Or, no.
4.
4. So if I go over 4, I go up how many? What's the square root of 9? 3. So 4, 3, it would be a point. So it's a sideways U. All right, there we go. I will upload the homework. She has 8 questions on it. It will be in the Google Classroom. That will be due on Monday. Great, and will you stop the video? All right, have a good day, everyone.